Okay, so let's talk about solving compound interest equations. When I talk about that, I mean solving for time. All right. Okay, so just recall compound interest, right? You're gonna continuously, well, not continuously, but you're gonna apply interest to a given amount, an initial amount, just over and over and over. All right. A is the final amount, P is the initial amount. They call it the principal, and then we have R as the rate, right, which is an annual percentage rate, and then N is the number of times you compound that particular rate per year, and that's our deal. Okay, so let's do this. If you deposit $2,000 into an account, right, and that account has a 4% annual percentage rate, compounded annually, so remember, it doesn't have to be compounded once a year, it could be multiple times, then how long will it take, right, for the account to be 3,500? So in essence, I'm asking, how long will it take for you to earn $1,500? Yeah, well, let's label out our pieces. Our initial amount is 2,000. We want 3,500. We have a rate of 4%, so change it to a decimal. And we're going to do this once a year, compound the 4% once a year. Right? We have no idea what the time is. That's what we're solving for. So let's plug it all in. Now we have this nice equation. Let's simplify this, right? So 1 plus 0.004 divided by 1, that's simply just 1.04. So I'd get in the habit when you're solving for time, I would multiply these together and simplify this inside, right? So my next step now, I have 2,000 times all of this stuff. And since the 1.04 is to a power, the inverse operation here is to divide 2,000. Right? I can't do anything to the base, and I can't do anything to the power. Right? So let's divide both sides by 2,000. And now notice I can reduce this. Right? First of all, the two, I can take out 100 from both. So, cross out the two zeros. And then 35 and 20, they both are divisible by 5. Right? So that's how I'm going to get this 7/4. Right? So I just reduce 3,500 divided by 2,000. Now we have an exponential equation. So a number equals a base to a power. How do we solve these? With logs, right? And we have two methods, right? I'm only going to do the convert this to logarithmic form. I'm not going to do the apply logs to both sides. So here's my base, here's my power, and then here's what it equals. So this turns into log base, right? That's the base. Remember, logs equal powers, so that's why the t is here. And then log base 104 of this left side. There you go. So then my job is to figure this out. So let's find a number for log base 1.04 of 7/4. The calculator duty, right? If you do this, you'll get 14.268 years. Right? I'd recommend doing a quick check. So, and this is a simple version, so I always go back to the original, but since it was 1 plus 0.04, I'm pretty sure I did this correctly. Right? So I plug it all in, and I get 3,499.85. Right? Some round off error. Whenever you're doing exponents too, you need to be accurate to a lot of decimals to get these close. Right? So just make a note of that. Exponentials, I carry them to at least 3 decimals. Right? Okay, so that's a good check. I'm happy with that. All right, so stop the video, and you want to do class work problems 1 through 3. Okay, so now how long will it take to double 5,000 if an account earns 4%? And this time we're going to do it quarterly. Right, so I want to just specifically double things. So initial amount is 5,000. If I'm going to double it, that would be 10,000. My rate is 4%, so 0.04. I'm going to go quarterly, so now it's 4 times a year, so I'll get an n of 4. Use my equation. I'll get 10,000 equals 5,000. And now here's where the once, pretty much every 3 months, right? 4 times a year. So notice I don't get 4% 4 times. I get 4% divided by 4. I get 1% every 3 months. Well, if you add that up, 1% every 3 months would be 4% total. Right? And that's why this is divided by 4. And then every year I compound 4 times, so I'll get 4 times the number of years. That's how many interest payments I'll get. Right? Okay, same thing. Let's add up both, or let's do this math first. Well, you don't have to. I like to do it that way. And then I'll divide both sides by 5,000. All right, so combine this base and then divide both sides by 5,000. So in this case, I did both steps at once. All right, so now notice 10,000 divided by 5,000 is 2. Now here's my question before we move on. Do you think getting a 2 is a coincidence? Right? So think about that. So if you think it's a coincidence, then forget it. If you don't think it's a coincidence, then what in this problem should have told you that this was going to be a 2? And in fact, if we knew that already, then it wouldn't even matter what we started with, right? So the amount of time to double 5,000 would be the exact same amount of time it would take to double 5 million, right? So think about that for a little bit. All right, so here's our equation. Same thing, logarithmic. So I have a base, I have a power, and then equals a number. So I'm going to do log base 1.01 of 2. Remember, logs equal power, so that's why the power is to the left side, or to the other side of the equal sign. Now it's 4 times t, so I want to isolate t. Divide both sides by 4. All right, this is just a number, so figure out what that is, and then divide it by 4. So you'll get 17.415 years. All right, always a good idea to check. So here I'm going to go to the original equation, 5,000, 1 plus 0.04 divided by 4, and then 4 times my answer, and see if I get a double. And again, we're dealing with exponentials, so this is pretty close enough. I think I'm doing some pretty good work here. All right. Okay. All right. So that's actually the end of the video. You want to complete classwork problems 4 through 7. After these, there are some other classwork problems, or some other ones on the classwork, right? So there's 8, I think 8, 9, and 10, but complete those as well. All right. But 4 through 7 goes with this section.